Cool. So I'm just going to take literally a minute to talk about some of the challenges moving from the sort of formal proofs realm into the let's bring this to a product realm, and harp on a little more about look-back parameters. And so we saw this with EC, we saw this with Photomet, which is sort of in the limit. We have convergence in the blockchain, but the question is, when it comes to people's money or storage being stored somewhere, the limit might not be good enough. Bitcoin has 60-minute confirmation time, and the question I guess that I'm asking with this sort of work is, can we sort of get to a tunable confirmation time that can scale in the number of miners, that can scale in sort of the time since last checkpoint or in the number of blocks, and that we can play with to get the product that we want and the guarantees to the users that we want. So this is just a quick show of the sort of work that we're doing around that to try and figure things out. So I'm running the simulation whose numbers I pulled this morning that show basically in a network with 100% rational miners, all mining on top of every available chain. What does the graph start to look like under different parameters? And so in this case, I'm going to do with a look-back parameter of 1, 20 miners running things for 300 rounds. We get something like this, which is going to appear somewhere, or not appear somewhere, one of the two.
Are you using Graphis?
No, it's a dot file parser, courtesy of Jeremy.
Oh, nice.
Here it is. So we have, so the 300 blocks means that the 20 miners generated 3,400 blocks. Yeah. And it is an absolute mess in terms of chain growth. So you can see that the width at every round is pretty constant, which is good, but it's obviously not fantastic when you are betting your storage or your money on a network and you have absolutely no clear sign as to where, which chain is going to win out. The fact that the width,
tons of orphans, or is there some kind of like?
So we're using like a ghosty protocol, so they're not actually orphans. But yeah, the fact that it doesn't get that much wider over time is good, but this is still not great in terms of the convergence time that we want. So to illustrate why, for example, we're thinking about look-back parameters is a great solution to this, let's change it to a look-back parameter of 20. Otherwise, the settings remain the same. And if we run this again, we see that our tree is a lot more manageable. And if we do this again, and it basically, as it should, given EC, in the limit moves towards a single block at every round, which is what we'd want optimally. If we move this to 90.
What is the LBP?
Look back parameter. It's how far back we're sampling our seed for leader election.
So you're actually looking 90 blocks back.
Exactly. And so obviously there's a trade-off here, which is if we look back, the leader and conversely can know in advance that they're going to be elected, and they can potentially run attacks like grind, for example, much more cheaply because they don't have to run an attack on every block. They know I'm going to win on block like 82, so I'm going to actually commit my money to attacking that particular section. So it's a trade-off, but it's a trade-off that we have to tune appropriately for the settings in which we're trying to build things. But I guess, yeah, that was my quick demo to show the sort of stuff that happens after you have a proof and you actually want to use the system in a production environment.
That's awesome. I guess the longer arrows are just like the null blocks?
Exactly. The longer arrows is like areas in which no leader was elected for a round. And so we don't show the null blocks, but those are null blocks. The block would have multiple tickets chained in.
Did you look at malicious nodes and just try to go back?
No, so that's one thing that needs to go into this. There are also, here everybody's rational. We need to try different proportions of honest and malicious nodes to try and see how it affects it.
It was really solid.
Cool. Thank you.
Thank you.